SV Math Teach here. If you like the sound of my gravelly voice and these free math videos, like and subscribe and help me out. Today let's look at linear equations. Now linear equations are going to be any equation that when graphed is drawn with a straight line. We should also clarify that linear equations tend to be functions. So those lines will be straight and they'll continue on forever. The ones we're going to deal with today are going to be proportional, which means they are going to follow that constant of proportionality, otherwise known as slope. And in this case, all of our lines are going to go through the origin. So here's an example. If apple X sells for $2 a pound, then its slope, or otherwise known as unit rate, would be 2. Now there's just a math statement, not a very exciting one, but there's a math statement, and underneath it I've done two things. On the left, I've graphed what this relationship looks like, and on the right, I've created some examples for what the relationship looks like. On the bottom, you can see of the graph that number of pounds is my x-axis and my cost is my y-axis. I've demonstrated with the black writing and the blue and red how I can calculate my rise and run, and how no matter where I start and stop, or start and stop, my slope continues to be the same. That should sound familiar. Good. I can also go over here and say, since all ordered pairs are x's and y's, I can take my y divided by x here and get 4 divided by 2 and get 2. 6 divided by 3 is 2. 14 divided by 7 is 2. So these things not only are linear, but they are proportional. They're proportional because these are all the same. On the graph, it's proportional because it goes through the origin. We can use this idea to write an equation. Y equals 2x. And in the context of what you see here, that would mean if you put the number of pounds here, multiply the number of pounds by 2, you're going to get the cost. So number of pounds is your x. That goes along with the x-axis. And the cost, or the total cost, will be your y. And that goes along with your y-axis, right? These linear equations do not have to be difficult. This is your slope or your unit rate. Now let's look at one other example, and then that'll be that. Here's an example of me trying to lose weight, right? The number of weeks I've been trying to lose weight and the number of pounds I've lost. Now in this case, my number of weeks is my x-axis, my number of pounds lost is y, and my graph appears not only to be a straight line, which means I'm consistently doing something. In this case, I'm going down and right. That means as my number of weeks continues to improve, as the number of weeks continues to grow, the number of pounds I lose continues to grow. Now the reason why I wrote it the way I did is because often we think of pounds lost as a negative, not a bad thing, but just like we've lost weight, so there's a negative result, right? Gaining weight would be plus, losing weight would be negative. So I really should probably throw a negative on all of these. Easy fix. And now we can go ahead and do some calculating. So with my blue and my red, I'm going to zoom in. You can see that from any dot to any other dot, I'm going down 1 and then right 2, or the equivalent of that, right? So here I have down 1.5, that's my rise, and my run is 3. Again, -1 divided by -1.5 divided by 3 would be -1/2. My slope is going to be -1/2, so I can write y equals -1/2 x, and that's it. Tells me two things. First, it tells me that at 0 weeks, I hadn't lost any weight. That's 0, 0. It also tells me that for every one of these things, in this case, number of weeks, I go down, I go down a half of something. In this case, a half a pound, right? So for every week, I go down a half a pound, and I end up being able to calculate, well, what would happen after 10 weeks? I put a 10 in the x, -1/2 times 10 would equal -5, and I could confidently say that if this were actually mapping my weight loss over a number of weeks, then after 10 weeks of effort, I would have lost 5 pounds. And that is how a linear relationship works.